Hello and welcome. In this demonstration, we're going to have a look at vSAN file services, and in particular, how vSAN file services, when they're consumed by Kubernetes to back read-write many persistent volumes, have a hard quota set against them. This is a question that has come up a number of times, so I decided I'd make a short video to demonstrate that. Now, as you can see in my environment, I have a number of clusters. They are all vSphere and vSAN clusters. And the cluster we're going to use here is cluster C, which is a 2-node vSAN cluster. Now, since the release of vSphere 7.0 Update 2, we can also support vSAN file service on a 2-node cluster. And what I've done is I've extended my Kubernetes cluster across all three of these different clusters. But for the purposes of this demonstration, that's not really applicable. We can just consider it as a standalone cluster. Now, first thing to show you is the storage policy, which will be consumed by the storage class. This is the policy that I'm going to use for my storage class. And here you can see it's of type vSAN, provides RAID 1 protection, and also just to differentiate it between the other vSAN data stores in this data center, I am setting or selecting a tag that's associated with that vSAN data store. It simply means that when we provision the persistent volume, that is the data store that it is going to end up on. Now I do want to show you how you can set quotas on a manually created vSAN file service. So let me show you here, file shares. At the moment, we don't have any file shares or container file volumes. But what I will do is I will go ahead and add manually an NFS share. And as you can see down here in the storage space quotas, I can create a warning, and I can also set a hard quota, something like that. Other things you can do, of course, is to set no access, allow access from any IP, or indeed allow ranges of IP addresses to access the file share. I'll just allow access from any IP. And so just review, allow access from any IP, warning threshold at 2 gigabytes, and the hard quota set to 3. Let's finish that. The file share should be created, should be visible in just a moment. Let me try and refresh it just to speed things up. And there we go. And if I look at the details view of this demo volume, you can see the various details that I've filled in there, which includes the warning threshold, the hard quota, and the allow access from any IP. So now what we'll do is we will switch to Kubernetes. We will request that Kubernetes creates a dynamic persistent volume that is backed by a vSAN file service file share, and we should see the threshold and quota information populated automatically there as well. Okay, so now we have an environment where I can access the Kubernetes cluster. And just to show you that I already have my storage class configured, you can see it there. And just to show you that this storage class is indeed referencing the storage policy that we saw earlier on the vSphere client. Okay, so the other thing to show you then is the manifest that is going to create the PVC, persistent volume claim, and the pods. So let's have a look at that. I've joined them all together. So you see the persistent volume claim is in the upper part here, and we're just requesting that we create a read-write many, which is a volume that can be shared between multiple pods. Size is 1 gig. And then there are two manifests for pods. So there's my app1 pod, which is accessing that file share. And here's my app2 pod, which is also accessing the same file share. And they're both mounting it on /mnt/volume1. And this command here is this just getting both pods to echo some text into a file that is located on the shared volume. The sleep command is just to keep the pod running. Okay, so with that in mind, we can now go ahead and apply this manifest. And shortly, we should begin to see the pods, the persistent volume claims, and the actual persistent volume itself begin to appear. And there we go. Now the pods are still in a pending state. They will come online shortly, but the persistent volume claim has been successful and the persistent volume now exists. You can see the requested capacity of 1 gig is there and its access mode is read write many. So now what we'll do is we'll switch back to the vSphere client and we'll just verify that there was a hard quota set with that persistent volume. So let's go back, let's refresh now, and we should see our new, yes, so there it is, it's a container file share. See, it's NFS, the storage policy that's consuming it, but now if we have a look at the details, more details about it here, but what we're particularly interested in is that the warning threshold and the hard quota is in place. So what this means is that the containers that are consuming this read write many file share file volume will only be able to write up to 1 gigabyte of data and no more than that. So that completes the demonstration.